Welcome to clickmyproject.com. Let me discuss the project about a variational model for histogram transfer of color images. In this paper, a variational model for intermediate color histogram equalization of two or more color images. Given a set of images, we transform them by minimizing energy function, which is composed by three different terms. On one side, we have a histogram matching term that tends to approach the cumulative histograms of the original images. On the other side, we have two constructive terms that tend to maintain color and images. The balances between these two opposite actions is important for our purposes. The original images in order to approach a common intermediate histogram. The proposed energy functional and shown that its results. The flexibility provided by the variational framework enables us to think about various developments of the proposed model. For instance, one could introduce a local color enhancement term to enforce the action of the algorithm discussed in this paper on images affected by color cost. This condition is quite common. In fact, most pictures are taken under some conditions that can be very different from the standard white light. Thus, the color cost is very likely to be present in the corresponding image. It's the block diagram of our project. First, we will load the variational color images, and the next one is pre-processing. Pre-processing Gaussian filter will be fine for input images, and the next one is cumulative histogram. Cumulative histogram, we transform them by minimization and energy functional, which is composed by three different terms. On one side, we have a histogram matching terms that tends to approach the cumulative histograms of the original images. On the other side, we have two constructive terms that tend to maintain color and images. The balance between these two opposite actions is important for our purposes. The original images evolve in order to approach a common intermediate cumulative histogram, and the next one is histogram equalization. Histogram equalization is the matching of color histogram is proposed in, and it's done on the three channels independently. The color histogram equalization is performed by computing a transfer map using mistransformations to fit the existing histogram to a uniform histogram. The formulation of color histogram matching in terms of compute a transport plan, which minimizes the total displacement cost between the two histograms that have to be matched. And the next one is mapping process. Mapping is the approach to color grading is based upon the computation of a color transfer map in case of color source and target values. The problem is to find a mapping in the space of colors that transform the source into one image with a color distribution as similar as possible to that of the target. We call this mapping the transfer map. Since we are mapping images to an intermediate histogram, it is converted to use the same image with different conditions. For this reason, we used two composite of pairs of images showing the same painting, which are taken by and with different limitations functions. The next one is result image for a final image. It's used to the some limited conditions. The proposed model, for instance, one could introduce a local color enhancement term to enforce the action of the algorithm on image affected by color cost. This condition is quite common. In fact, most pictures are taken under limited condition that can be very different from the standard white light. This color cost is very likely to be present in the corresponding image. Now let's see about the execution part. I am having main.figure file, then select the file, right click, open in guide, run the figure file and select the load image button. Here we have to select the original image, and next pre-process. Gaussian filter will be fine for input image, and next cumulative histogram. Cumulative histogram of the transformed image. By definition of cumulative histogram, the process described has an important limitation, and cumulative histogram of each channel for red channel and blue channel, and next green channel. And next select the histogram equalization. Histogram equalization, the transfer map is computed by iteratively equalization. All axis is computed by iteratively equalization signals computed for very possible rotation of the histogram. And next color adjustment process. Color histogram equalization of finding a midway histogram in the sense of distance and computing sense of distance and transform the original image into images that share the histogram. And next, select the color adjustment process. This color adjustment process is used to the mapping is a variable histogram to a reference one. Mapping is an intermediate histogram. It is converted to use the same image with a different color adjustment by limitations. Mapping in the space of colors that transform the source into an image with a color distribution as similar as possible to that the transfer mapping. Finally, as a result, while approaching an intermediate histogram between them, this intermediate histogram is a natural result of the model. Finally, the visual adjustment is used to perform in line with a midway histogram equalization. A color is very likely to be present in the corresponding image. Then this image is separated to the red channel and green channel, then blue channel. In real time, it will be applied in Cine field to adjust color and contrast is the video and images. Thank you.